Right, so we're pretty much ready to run our cache here. I just want to organize this a bit better before I forget. I noticed I should just put the names here. And let me see, the stitch is, what's that doing? The collar. Okay, and then also in this weld, which is here, I just want to turn on braking, set that to 1. Okay, so because I want to change that as we progress through the simulation, right? So the longer into the simulation, the weaker I want that to become. So I can't animate it here, so I'm going to do that inside the solver, right? And we're also going to be animating, if you remember, the left boot, right? So we don't need to turn on braking here, but within the solver, yeah, we can basically delete those constraints at a certain point, right? So if we look at the crocodile simulation, the animation, you know, there's a part here, so he flips over, and I think, yeah, around there, so the body's going to be flipping round. Well, actually we can see here he's going to be like that, and I think it'd be good if the boot kind of flies off as he's flipping over. Okay, so at about frame 70, if we delete those, then the boot will fly away. Okay, so let's make sure we're before frame 140, so we're going to do some things. Maybe I'll just turn off the solver here. If you click on the brain, it will stop the simulation. Go back to the first frame, in fact. Jump inside our AutoDop network. One thing I noticed straight away, this pop drag is in the wrong place. That needs to be in the middle. Connected into particle forces here. I just put it there stupidly. Let's see, also I've got 5 sub-steps out here, and also 8 on the outside. Just 8 is enough for us on the outside there. Okay, so everything else here is fine. So we're going to add in a couple of new nodes here to break those constraints, right? So we're going to drop a vellum constraint property. So you can use this to make changes to constraints during the simulation. Okay, so this is, you can build constraints, new constraints with this. You can turn it on at certain points, and you can also turn off constraints. You can affect you can't build constraints with this, but I think if let me just search. Well, on constraints, yeah, so you can use this to build new constraints as the simulation goes on. So if you want something to stick to a wall, or for example with this simulation I tested out sticking the body into the mouth whenever they go close enough. Maybe I'll show you that later if we have time. You can do that with this, but what we're going to do is grab those boots, so we'll have to come to frame 140 to see the group, and turn on the simulation just to frame 140, and then hopefully here will show me my left boot. Okay, that's the group of constraints that we made. Okay, and then what I'm going to do is turn on remove. Okay, so that will delete the constraints basically, and to control the time of that, I'm just going to put on $F is more than 170. Okay, so at frame 170, this will become active, and it will delete the constraints which are attaching the left boot to the body, and hopefully it will fly off. Okay, now also a bit more complicated, okay, because as I said, the welds, you can't see them here. Oh, actually, maybe, do we have a visualizer? Yeah, and here in the vellum object guides, we have all these same visualizers here. We can see the welds. So these are not constraints, so we can't control them with these. So we're going to use a wrangle. Okay, geometry wrangle. Also connect that up here. Let me give this a name. Left boot. Geometry wrangle will be welds. Okay, and let me see for groups. Well, we'll just leave that blank. I think that should be fine. Well, we'll do all groups except for the hunter, just in case. So it's not working on the tetrahedrals, right? So we'll just be working on the cloths. And so we have this attribute, break threshold, like this. So this attribute is created when we turn on that breaking in the constraints. Where are we? Not the pin, in the well, not the collar either, the cuts here. So this will generate a break threshold there. Okay, and then we can access that in this stream. So what I want to do is kind of weaken it in regards to the time. Okay, so I'm going to use a fit, not fit 01, because we're not using values between 0 and 1 now. So I'm going to base this on the frame number. Okay, so from frame 140 to frame 200, so from the beginning towards frame 200, the break threshold will drop down by these two values now. Okay, so from 0.075 to 0.005. Okay, pretty much to 0, so all of them will break towards the end. Okay, so at frame 140, the break threshold will be 0.005, 0.075, and then at frame 200, way into the simulation, it'll drop to this, and most of those welds will break. Okay, and you know, all the cloth will be ripped open and look cool, hopefully. Okay, so I think that we're pretty much ready to go now. I'm just going to push this up to 5. I don't think it tells you here inside the solver, but if I go out here, go to this Vellum intro, I just want to look at this Vellum solver. So it's the same thing, this post collision passes. If you hover over, it says, after all constraints are performed, a final round of collision detection is done, blah, 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 blah. And it says the recommendation is the number of stacked layers plus 2. So it's basically looking at, you know, if you've got layers of vellum on top of each other, then you should push this number up. And we've got, you know, we've got the tetrahedrals, and then we've got the cloth, and in fact we've got 2 layers of cloth here. So there's 3, you know, we've got the boots on top and everything. So, you know, just for safety, I'm pushing this up to 5. Okay. But the rest of this I'm leaving at default, everything in here at default as well. So let's try caching this out. Let's see. So we haven't actually gone into here yet. So this was generated when we used the shelf tool. So here we're importing the actual geometry from the sim, removing the normals for some reason, but it doesn't really matter, and then setting up new normals. I believe are just visualizers for them. Do we have actual normals here? Well, I don't know. I don't need to worry too much about that. And then here on this side we're importing the constraints, okay, which isn't essential but can be useful for this Vellum post process. Okay, you can do certain things with these constraints. All right, and what we want to do is cache this out using this Vellum IO. Okay, so this is handy because it will just like before with the drape, it deletes all the stuff which are only, all the attributes which are only needed for the actual simulation itself, and you know that will just take up space in a hard drive that you don't need. So I'm going to cache from frame 140. So right click, delete parameters channel, sorry, to get rid of that that $F start, I think it says. Frame 140 to 240, that's fine. Well, actually, I think if I remember correctly, let me just go back into this simulation, this animation. I think we've got a bit more than that. Yeah, if I'm just going to change my duration. I think it goes to 250. It's animation. Why not? It's up to you, but I think that's the end there. Okay, back into here. Oh, press escape. That's my mistake. Just trying to simulate all the way through now, so go back to that first frame, 140. Okay, and then give this a good location. Let's drop this in the sim folder. I don't want to give it the hip name. I'll call it let's see, body, and let's see, body and cloth dot version 1 / that will make a new folder for me. If this is checked, creates intermediate directories, and then I'll just, the actual file name will be this as well. I don't want to give it this value my own name. Get rid of this dot. Version 1 again. I don't want a folder there. The dot $F3. So we'll have, you know, because we got hundreds. Bgeo. I'll just have Bgeo. And I think that's all good to go. Load from disk now before I forget, and then we'll save that out.